Okay, let's start by answering question 1 here on the left-hand side. We're going to draw the isoquants, which are going to be the combinations of K and L that produce the same output. Remember, the shape of the production function is A, the minimum of alpha K and beta L. Notice one key thing, which is a key insight here to know how to characterize the isoquants. Suppose that you have a level of K and L in which the two numbers are the same. So let's say that this is 1 and this is 1, for example. Once you're at that point, adding extra L doesn't increase the production. It doesn't increase the production because the amount of output is determined by the minimum of the two numbers. So it's kind of wasteful input. The same is true if we're at 1, 1, and then we add extra K. So what that should give you the intuition is that basically there is going to be a ray coming out of here that I will characterize in a second that has the property that at that point alpha K and beta L are the same. And once you add either more K or more L, you don't get anything else, so that the isoquants basically look like this. And that would be for different levels of production, let's say for a level Q1, a level Q2, and a level Q3, with Q3 greater than Q2, greater than Q1. Now the question, of course, is what is that, the slope of that line? And that line is characterized by the condition that the two levels of the inputs are the same, so alpha K is equal to beta L, which implies that L is equal to alpha over beta K. So the slope here is alpha divided by beta. And that gives us a full characterization of the isoquants. Now, let's answer question 2. Let's try to see if the function satisfies CRS, DRS, IRS, or neither. So what we have to do there is to ask the question. It's what happens if we start with K and L and multiply the level of inputs, we amplify it, or scale it up by lambda. So let's ask, what is the F of lambda K, lambda L, for any lambda greater than 0? Well, that is going to be equal to just substituting A, the minimum of alpha lambda K, beta lambda L. Now, this is a key step here. If you have the minimum of lambda one number times lambda another number, you can bring the lambda out. So this is equal to A lambda, the minimum of alpha K beta L. But then this is equal to lambda F of K comma L. And this is exactly the condition for constant returns to scale. So Aliontiev production function satisfies constant returns to scale.